LangGraph's interrupt mechanism enables dynamic execution pausing within computational graphs, allowing external input to influence workflow progression at precisely defined points. This pattern facilitates human-in-the-loop interactions by suspending stateful computation while preserving context through persistent checkpointing. The upcoming code demonstrates how interrupts behave when invoked within nested subgraphs, revealing the re-execution semantics that occur upon resumption. You'll observe how both parent and child graph nodes restart from their entry points when execution continues, with the interrupt payload serving as the communication channel between suspension and resumption phases.
Def node in parent graph state. Some code hash. This will re-execute when resumed. Hash invoke a subgraph as a function. Hash the subgraph contains an interrupt call. Subgraph result equals subgraph. Invoke some input. Hash. Def node in subgraph state. Some other code hash. This will also re-execute when resumed. Result equals interrupt. What's your name? Hash.
This code demonstrates how interrupts behave when used within subgraphs in LangGraph. The key pattern here is that when a subgraph containing an interrupt call is invoked from a parent graph, both the parent node and the subgraph node will re-execute from their beginning when execution resumes after the interrupt. The mechanism works by having the parent graph call, subgraph, invoke, which triggers the interrupt in the subgraph's node. When resumed, the parent graph restarts execution from the beginning of the node where the subgraph was invoked, and similarly, the subgraph restarts from the beginning of its interrupted node. This behavior is important to understand because any code before the interrupt call in either graph will execute again upon resumption. This approach is useful for human-in-the-loop workflows where you need to pause execution at specific points in nested graph structures. However, it requires careful consideration of idempotency for any operations performed before the interrupt calls, as they will be re-executed when the graph resumes. The pattern also maintains the strict index-based matching of interrupt calls that LangGraph uses, ensuring consistent behavior across node executions. Let's break it down.
Def node in parent graph state.
Defines a function named nodeInParentGraph that takes a single parameter, state, of type state. The function signature indicates this is likely a callback or handler that will process state information, but the implementation details aren't visible in this segment.
Some code hash. This will re-execute when resumed.
Calls the sumCode function and includes a comment indicating this function will be re-executed when the workflow is resumed. The comment suggests this line is part of a checkpointable or resumable execution flow where certain operations may be repeated upon continuation.
Subgraph result equals subgraph. Invoke some input.
Invokes the subgraph, objects invoke method with some input as the argument, executing the subgraph's logic and storing the result in the subgraph result variable. The operation processes the input through the subgraph's defined workflow and returns the output, which is then assigned for potential further use.
Def node in subgraph state.
Defines a function named nodeInSubgraph that takes a single parameter, state, with type annotation state. The function signature indicates it will operate on a state object, but the implementation details aren't visible in this segment.
Some other code hash. This will also re-execute when resumed.
Calls the function someOtherCode, which will execute its logic, and, as indicated by the comment, will re-execute when the workflow is resumed.
Result equals interrupt. What's your name?
Calls the interrupt function with the string argument, what's your name? And assigns the returned value to the variable result. The immediate effect is that the function executes with this specific prompt, and whatever value it returns gets stored in result for potential later use. The interrupt mechanism in LangGraph creates a clean separation between suspension and resumption phases in nested graph execution. When an interrupt occurs in a subgraph, both the parent and child nodes restart from their entry points upon resumption, with the interrupt payload serving as the communication bridge. This re-execution behavior means any code before the interrupt call, whether in the parent's, some code, or the subgraphs, some other code, will run again, requiring idempotent operations for predictable results. The pattern maintains strict index-based matching of interrupts while enabling human-in-the-loop workflows through persistent checkpointing. The key insight is that interrupts don't just pause execution. They reset the entire call stack to the node boundaries, ensuring consistent state management across nested graph structures.
The subgraph dozes through interrupts, yet its state answers calls it never took.